Alright, today we have topic 4.3, parallel lines and algebra. In our previous lesson, we did parallel lines investigation, and we talked about when we have a set of parallel lines that are cut by a transversal, we figured out the angle pairs, whether they were congruent or supplementary. Well, in this lesson, we will take that knowledge and we will add some algebraic expressions to that and solve. Alright, so let's begin with the first page of the notes. And here it says, through our parallel lines investigation, we learned when parallel lines are cut by a transversal, we'd ask which pairs of angles are congruent. So if you look back on your previous notes, this is where you will gather this information. We've already established this, but congruent angles, we have corresponding. We have alternate interior. We have alternate exterior. Now, which pairs were supplementary? Well, we had same side interior and same side exterior. So I can write that a little bit neater there. Same side interior and same side exterior. Alright, now which pairs was always congruent regardless of whether or not they're parallel? This is the ones that by definition will give us the congruency. These are our bow tie or our vertical angles. Vertical angles. Go down the page just a little bit here. Okay, which angle pairs were always supplementary? By definition, a linear pair will always add up to 180. Alright, so let's look here at our example 1. It says tell what type of angle pair each is and tell whether they are congruent or supplementary. So here we are, we're looking at 1 and 3. Now, our first thing that we should look for is to see whether or not we have parallel lines, and we do in this case. So, 1 and 3, what type of angles are they to begin with? They are corresponding. They're on the same side, but they are neither both on the interior nor both on the exterior. So, corresponding. Now, are they congruent or supplementary? They are congruent. Another symbol that you will see for congruent will be that, the equal sign with the little wavy line over the top. Alright, now let's look at angle 3 and angle 6. Alright, so definition, we know that 1 and 6 are our vertical angles, so they will be congruent. So we know also that 1 and 3 are congruent. So if 1 and 3 are congruent, 3 and 6 also must be congruent, since 1 and 6 are. Alright, what type? They're both interior. They are not on the same side, so they are alternate interior angles. And they are congruent. Alright, 4 and 5. We're looking at angle 4 here and angle 5 here. Alright, these angles, they are both exterior. They're not same side, so they're alternate exterior. Look up at the top of the page. These angle pairs show to be congruent. So alternate exterior, and they are congruent. Alright, 2 and 3. 2 and 3. Let me grab another color for 2 and 3. We have 2 here. And we have a 3 here. Make this line a little bit easier to see. Alright, so now we're comparing 2 and 3. They're on the same side of our transversal, and they are on the interior of our other two lines, which are parallel. So they're same side interior. Look up at the very top of the page. Same side interior angles. They are supplementary. So, defining them, they are same side interior, and they are supplementary. 1 and 6. 1 right here. 6 right here. We've already talked about 1 and 6. 1 and 6, they are vertical. They make the bow tie. I'll go ahead and rewrite this a little bit neater here. Vertical. And seeing as how by definition they are always congruent, so we can put that they are congruent. And lastly, we have 1 and 4. 1 and 4, those are the two that we're looking at. Alright, let's see what we can take out of this and how we can determine. These are both on the same side of the transversal, both on the left side. They're both exterior. Looking up, same side exterior angles. They are supplementary. Same side exterior. And they are supplementary. Alright, so now let's move on to the second page of our notes. Here it says, for each of the examples below, identify the type of angle pair, and given that lines L and M are parallel, that's our key word right there. We know that L and M are parallel now. Find the value of x. So here's our algebraic expressions. Quickly, I'm going to come over here. I'm going to mark here at example 2. Here's my interiors. So they're not on the same side, but they are both interior type of angle pair. We have alternate interior. Now, what do we know about our alternate interiors? They are congruent. If they're congruent, they are equal to each other. If two things are equal to each other, I'm going to write it down up here. I've got my first one here. Let's say that's my first one of a 2x minus 10. We're going to set that equal to our second one. This will be my second one that I'm going to write down. It doesn't matter what order we put this in, but this will be a 3x minus 40. Alright, so we're looking to work this down. Let's get our x's on one side. Plus 10, plus 10. You can go ahead and we can subtract 3x from both sides. So what this will do would be we're going to move our x's. Our x values will move. And then our other values will move to the other side. We get this, we will have a negative x equals, we have a negative 40 plus 10, negative 30, multiply both sides, by a -1, we'll then end up with an x equals a positive 30. So it's asking right here, what does x equal? 30. All right. Example 3. There's my interior. Now, right here, our angles, they're on the same side, but they're neither both interior nor both exterior. That leaves our corresponding. So that's our type of angle pair. Corresponding angle pairs are equal. So once again, I'm going to come up here. I'm going to grab one of these. Let's see here. I'm going to grab a 4x. Well, let me go ahead and get a different color here. That way we can kind of see where I'm grabbing some of these from. We've got, this will be my first one here that I'm going to grab. 4x minus 30. We're going to set that equal to our second one of a 2x minus 14. Now it's simply working this out. Subtract 2x, subtract 2x. I'm going to add 30 to both sides. And we're going to work out and see what we get here. We will have a positive 2x. 30s will cancel. This will cancel. And on this side, we will be left with a 16. Divide both sides by 2. X equals 8. Example 4. Mark my interior. Help get a visual of what's interior and exterior. Here we're both on the same side of the transversal and we're both interior. So we have a same side and we determine that these are interior. It's the type of angle pair, same side interior. Going back to previous notes, what do we know about same side interiors? They're supplementary. When added together, they equal 180. So we know that when you add these two together, grab a color here, when they are added together, they equal 180. So now all we have to do is simply fill in. We have a 5x minus 32. This 5 look a little better here. And now we also have an x plus 8. All right, so combine like terms. We have something with an x. We have a 5x and a 1x. That's going to give you 6x. We have a negative 32 and a positive 8. In the end, that will leave you with a negative 24. All of this is set equal to 180. Add 24 to both sides. That will eliminate it from this side, leaving you just a 6x equals, do the math here, 204. Divide both sides by our 6. That will give us our answer of x equals 34. X equals 34. All right, so let's move to the final page of our notes. This is where it goes ahead and skips to our example 6. But we know that here's our L and here's our M. Now it's stated before, these are parallel. So now what we have to look at is we have to determine our X and our L. If this line continued on through, and we can draw this. Let's say this line right here happened to continue through. And we can also say this line here continues on through. So at this point, we're going to use this to try to determine our x. Now, these are not on the same side, and they're neither both interior nor exterior. So therefore, we don't really have an angle pair type. There is none. What we have to look for now is a way to solve this. Whenever we go on through with this line here, we have created a what pair? These two right here are a vertical pair, so that's going to cause this to equal x degrees. So now we have, you can look at these two, and we can say, well, this is, they're on the same side. Here's our transversal. Let me go ahead and mark. If you draw this, this is our interior. Here's our interior, because here's our two lines and our transversal cutting it. So we have the same side of the transversal and their interior. Same side interiors do what? They add up. When you add them together, they equal 180. So I'm going to take my first one here, 3x minus 40, and then I'll grab my second one, just simply an x. Alright, so we can roll through this math fairly quickly. We have our like terms that we can add together. Will give us a 4x minus 40 equals 180. Add 40 to both sides. We'll cancel out there. You'll be left with a 4x on one side equals 220. Divide both sides by 4. You will get x is equal to 55. Come over here and put this into my answers. X equals 55. And our last one, example 7. Find the values of x, y, and z. X, y, and z. So here, let's look at what we can determine. We have our two arrows on this. That's going to signify that it is parallel with this line down below. And we also have parallel lines running right here. So we can look at these as two different sets of lines being cut by transversals. And in order to do this, let's see where we've got an x here, a y down in this direction. So let's imagine that we're looking at, here's where you have to take, and granted that is not straight on that, but we're going to take these two lines and we're going to use this and this one being our transversal. Let me grab a whole nother color for a transversal here, make it stick out a little bit. I know that is not down the line, but now we can look and see what we have. We would have our interiors would be all of this area here would be our interior. These would be same side interior, but you cannot put a 3x equal to, or 3x and a 2y equal to 180. That's not going to help us solve, but what do we do know about an 18? An 18, we can revolve around this 18 because it is a number that we actually know. And we can use this 18 to solve quite a bit of things, actually. We've got an 18 here, and if we're looking at try to find something that is congruent. So our alternate interiors, which is 18 and 2y, are congruent. So we can come over here and we can say our 2y is equal to our 18 degrees. Well, this will help us solve for y in this case. And now we can say we divide by 2, our y is equal to 9. Over here and put this down. Y is equal to 9. Now, what else can we look at? If y is equal to 9, we know that this here is 18. What else have we formed? We have formed a couple of different things that we can use to solve here. We have a triangle. We have a triangle here. What do we know about a triangle? We know that all the interior angles of a triangle, you should have known this, they add up to 180. So now we can use that to solve. We have a 63 degrees plus we have a 3x in this corner. And then here we know that this together is going to equal our 18 plus 18. We know that all those added together in the triangle equal 180. So we're going to go ahead and combine our like terms. We've got a 3x, and then we're going to end up with a positive 63 plus 18, 81, equals 180. Subtract 81, 3x equals 99. Divide both sides by 3. That will leave you x equals 33. So here we go. We've solved for both of those. And now we need to solve for our z. Now we're going to go back and we know what x equals. X equals 33. So if we plug this in 3 times 33, what does this have for this angle? This angle is 99. Now we can look back and we've got our transversal cutting. We've got our alternate interiors, alternate interior angles. Irregardless, alternate exterior or interior, what do we know about those? They will be congruent. So we can set our 11z equal to this side, which is a 99. That will leave you with a z is equal to a 9 as well. So what we wanted to determine on this was in which way do we need to cut using a transversal and 2 parallel lines in order to find something that's congruent, and which ones to choose, all bases off of what we actually know. Something that does not have a variable off of it. We found our 18 degrees. So if we wanted to find a pair, something that would be congruent to our 18 degrees, we would need to use this as our transversal, this line, and these 2 lines as our ones that are running parallel, to be able to use our alternate interior and prove that those are as well. What you could have come over here and said, we could say our 2y equals 18 at that point, and we can also say that 3x equals 11z. We know that as soon as we define our 2 lines in our transversal, we now know that this down here is true. We could have said this from the beginning, and in the end, that's how we worked it. This would have been our 3x. Right here would have been our 3x. You actually work it out once we solve. When we solve for a y, when we solve for an x, you use that to solve for the rest of them.